Hi, this is Peter Jacobs with CalcBook, and today we're going to be looking at beam loading. So we're going to be looking at some shear and moment diagrams. So let's go ahead and get started. So our problem statement for today, we're going to be looking at a W10 by 45, so that's A992 steel. The length, loading, and fixities are just shown below in the diagram. We are going to be including the self-weight of the beam in the calculations. And the goal for today is just to develop the shear, moment, and deflection diagrams. So we've got a 20-foot long beam. It's a simply supported beam, so it's a pin on the left side and a roller on the right side. We've got a live load, distributed load of 1.5 kip per foot. And then we've got 2 point loads, both dead loads. The first one is a 3 kip load at 3.5 feet from the left side. And then the second one is a 5 kip load at 13 feet from the left side. So let's go ahead and open up CalcBook for this, and we can start to produce our shear, moment, and deflection diagrams. All right, we've got CalcBook open now. So we're going to go ahead and go right into our steel design module. We're going to click on member design, and then we're going to go straight into steel member. And then for today, we're just going to look at flexural design. So again, on our left side here, we're going to go ahead and select our W shape. We're going to scroll down to select a W10 by 45. And then you can see here, this is a new feature in CalcBook where you can utilize our beam loading tool. So before it was only just manually enter loads, and now we have this beam loading tool. And we're going to be using the ASCE 7 loading. So we'll go ahead and click right into our beam loading tab. So you'll see now this is all new for CalcBook. We just released this. So we're going to be walking through some of the different options and selections that you can make when utilizing the beam loading tool. So first thing is whether or not you want to include the self-weight, right? So you can toggle that on or off. We're going to leave that on for this problem. And then we have an option here to rotate the beam 90 degrees. So this really applies to just the self-weight of the beam. So if you rotate it 90 degrees and you're looking at it about the weak axis, right, you can select this and that will automatically put the self-weight of the beam against the weak axis bending. So for this problem, we're going to leave it about the strong axis, right? Then we need to enter the length of our beam. So we had a 20-foot beam. We have this analysis location, right? So in CalcBook, you as the user can select where you want to take your shears and moments and deflections from these graphs. So for now, we're just going to enter the midspan of the beam, right? We have an analysis location at 10 feet, and you can see that red dotted line that pops up there. So you can see this move. I put it in 5 feet. It'll jump over here, and you can see what the loading is at that location. But for now, we're going to leave this at 10 feet. So we keep moving down here, the input window, right? We come to, you have an option here of strong or weak, right? So for strong axis loading, this will be what you want to use. And if you have weak axis loading, maybe you're doing a beam column or something like that, and you have loading in both directions, you can go ahead and go over to the weak axis and you can add your loading in here. If we go back to the strong axis, right, you can see that we've already got the self-weight is automatically populated over, and you can see that, you already have your sort of typical distributed load diagrams going on here. But we need to add in our live loading. So we're going to go ahead and click on the live load button here. We're going to go to our drop down uniform load, and then we're going to add in 1.5 kip per feet. And we'll save that. And then we have to add in our 2 dead loads. So we go click on the dead load. We're going to add some point loads here. The first one was 3 kips at 3.5 feet from the left side. Right, you can see the charts already starting to update based on that. And then we're going to add one more point load, and that's going to be 5 kips at 13 feet on that side. Great, so now you can see here we've got our dead load and our LRFD load case 1. So you can go ahead and select the drop down here for whichever load case you want to view. And for this one, since we have dead and live, we're going to select the second load combination here, which includes our 1.2 dead and 1.6 live. It's important to note here that when you're doing the design, so when you go over the design tabs, whether it's flexure or shear, that's going to automatically pull out whatever the most critical load combination is. So this drop down here is really just for viewing purposes. So if you want to see, what your earthquake loading is going to look like, or your dead plus live, whatever it is, right, you can select and view that here. Or in the case of deflection, right, if you want to look at your live only, right, you can scroll down here and look at your deflection for live only. But when you go to the actual design tabs for flexure or shear, it's going to automatically pull the correct load combination to give the critical load combination situation. Okay, so now that we've got our loads entered, where we can see our graphs here, right, we've got our shear, our moment, and our deflection. Now we're going to go over and click onto the flexure design tab. And we need to enter a bracing configuration. It didn't say in the problem statement, but we'll just go ahead and say it's fully braced. Right, if you click to the demand tab, you'll see that it's already pulling over the loading for each load case based on the moment diagram. So we've got 25 kip feet of dead moment and then 75 kip feet of live moment. And then like we've done other videos and other designs, right, we can go through, we can check all the different aspects of the calculation for the capacity of the section. And then finally here in our output window, right, we get our capacity of 205 kip feet and our demand of 150 kip feet and a DC of 0.73. So the design is okay for this one. And that's the kind of a look at the new beam loading tool that we have in CalcBook. I hope you liked it, and please go and check it out.